Have you ever been working on a project and making great progress? You could see the end in sight. You were plotting out your timeline. You knew exactly when you were going to submit. And then a whole bunch of other stuff came up in your life that forced you to put your project on hold, take care of those other tasks, and come back to it. Well, that happens to me a lot as a professor, where I'm working on my own projects, and then I have to do things like write a grant proposal, I have to teach, I have to work on other people's papers in my lab, and then I come back to my work, and I look at it and think, what the hell was I thinking? Hey folks, I'm Pat Schloss, and this is Code Club. In each episode, I try to show you how I apply principles of reproducible research to an interesting biological problem. We've been spending the last 60 or so episodes working on a single project where we were making awesome progress. And I could see, as I was kind of charting forward future episodes, that, in the next week or two, we'd be ready to submit this. And I could show you the inner workings of submitting a paper and posting things to bioRxiv. And we were set to kind of put a wrap to this project for the time being. But what happened, like many PIs or many people, is that I had a grant deadline at the beginning of February. And so that forced me to make a number of video episodes all in a couple days and then release them over the couple weeks that I was working on this grant proposal. But what that afforded me was some time to let the data breathe, let the analysis breathe, let the data in my head kind of fester a little bit and think more about the project. One of the things that hasn't quite sat well with me is that in the supplementary figure 1, which is a receiver operator characteristic curve, also called a ROC curve, you'll recall that curve is really smushed into the upper left corner, indicating that really, regardless of what threshold we use to define a cluster, whether it's an ASV or an operational taxonomic unit, we have really high sensitivity and specificity. But juxtapose that with what we have in figure 2, which shows, as you increase the threshold, the amount of splitting falls off, but the amount of lumping across species really increases. And so through some email that I received and just my own thinking over the weeks that I was working on this grant proposal, it occurred to me that the ROC curve is kind of a bad way to represent these data. That the number of negatives, the differences between different species or different genomes is far larger than the number of positives or the linkages within a genome or within a species. And because of that, you have this weird skew, making the ROC curve kind of an inappropriate way to represent these data. The other thing about a ROC curve is that they really give too much credit to our taxonomic system, right? So as I've mentioned many times in these videos, the species concept for bacteria is really poorly defined and kind of arbitrarily applied to different taxa we have. That like Bacillus cereus, Anthracis, and Thuringiensis are basically the same species, yet because we're biased and because they cause different diseases or have different phenotypes, we put them into 3 different bins. And they largely differ in the plasmid content, not so much on their chromosomal content. So again, that's an element or an aspect of bias, and that goes in both directions. Like people split genomes, split species apart, or they merge them together, make kind of what I call garbage can taxa, where you just kind of throw everything in there. Anyway, so the ROC curve really puts too much emphasis on that definition of what we attribute to as being a species. Also, over the last couple of weeks, I've talked with a number of people about this project and the results, and asking them whether or not this story resonated at all with them. And they thought the part that really resonated the most was this aspect of splitting genomes apart. That if you look through some of the papers, like Data 2 or for UNoise, they really kind of dismiss, and they're very dismissive of this risk of splitting genomes apart, and they don't seem to think it's that big of a problem. And they're really beholden to this idea of bacterial species names effectively not being biased, right? They don't say that they're not biased, but they just kind of assume that they're a good representation of biological diversity. And so I think it's really important then to focus on this splitting aspect. The other thing that bugs me about my analysis of those ROC curves is the paragraph in the paper that we currently have is a little bit confusing and a little bit jumbled. There's a lot there to define all these parts of the confusion matrix, and I don't really think it helps move the story forward in any meaningful way. The other aspect is that the paragraph describing the lumping and splitting, if you read through it, the first half of it talks about, what threshold would you need for a genome with 7 copies of the operon to be collapsed down to 1 OTU, And the second half talks about this rate of lumping and splitting across all species for different thresholds. And so what I think would be better to do would be to split that apart, get rid of the ROC curve paragraph, and kind of build out those paragraphs a little bit more to talk about this aspect of splitting genomes and how the risk of splitting a genome apart increases as you increase the number of copies. And so that really calls for an even larger threshold. In addition to modifying the text, what I'd like to do is get rid of that ROC curve, and I will create a new figure that shows on the x-axis the number of copies in the genome, and we'll have 4 lines for the 4 different regions we're looking at. And the y-axis then will be the threshold that needs to be used so that 95% of the genomes or species collapse down to 1 OTU or ASV. So that will become figure 1. And the current figure 1, you'll recall, is the rate of ASVs per number of copies of the rRNA operon as a function across the x-axis of the number of genomes in each species. So I'm going to take that figure, which I still think is really compelling and useful, and put that in the supplementary figure. And I'm going to put it in the supplementary material because, again, I really want the story to focus on this risk of splitting genomes apart. And again, what I want to underscore is that taking the time, taking a couple weeks to think about the data and to think about the paper, as frustrating as it was to not be able to kind of plow ahead with the analysis, really gave me time to think about the data, to talk to others about the data, to kind of share that story, and to hone the message even better. So even though it's frustrating to slow things down, in the long run, it's really going to make the paper, I feel, a lot more robust. All right, I'm going to go to my project root directory, and I'll go ahead and open up my manuscript. So again, the problem with the ROC curve is this third paragraph of the result, what I've been calling my results section. I'm going to get rid of this. And up ahead here was this second paragraph of the results section. And you'll see that in here, like kind of the first half talks about what's going on for genomes with 7 copies of the rRNA. And then it goes to looking at the resolution for splitting and lumping across all thresholds and all regions, or all numbers of copies. And that makes the paragraph a little bit confusing. And when I read through this, it's not quite clear that the type of analysis is changing. So again, what we'll do is we'll pull this apart. We already have figure 2 for the second part. And so we want to make a new figure 1 for the first part. And this figure 1 that we had up here will become figure S1. All right. Let's go ahead and fire up RStudio. So to create that new figure 1, I'm going to go ahead and create a new R script, which I will save in code as plot copy number threshold. And we'll start with library tidyverse, so we can have all those goodies. And we'll do source code /colors.r, which will bring in our coloring scheme for our project. Go ahead and load those. And I will then do read TSV, and it's going to be in data processed that we had the thresholds for single OTU TSV. And loading that again, we can look and see that we have a data frame with the region, the number of copies, the threshold, the IQR, and the number of genomes, which is all good. One thing that we'll come back to is that we might want to use the number of genomes as a filter to remove copy numbers that don't have, say, over 100 thresholds, because the data can maybe get a little bit wonky when we don't have a lot of representative genomes for each number of copy. All right, so we can then pipe this to ggplot AES, and our x-axis will be the nRNs, and our y will be the threshold, and our colors will be the region, and we will do a geom line, okay, and we'll run all this, and for some reason, I think this should be color. Yeah. Again, it gets kind of jungly, jittery, whatever you want to call it, out here to the right, kind of at like 9 and beyond. And I think what's happening is that there's just not a lot of copies or not a lot of genomes representing these copy numbers. And again, if we look at the output of this, we can see that at 10, we fall below 100. Maybe what I'll do is I'll go ahead and do a filter on n genomes greater than 100. And this should, again, focus on those number of copies where we have a good number of genomes in the data set. So this is the basics of what I want the plot to look like. Now what we want to do is clean this up and make it look publication worthy. Eventually we'll turn this into a TIFF or a PDF, but for now there's a lot we can do in here to start making it look nice. Things that we've seen in a lot of other episodes of Code Club to make it nice, so we can make it look theme classic. We can do my color. What did I call that thing? Color, not color converter. Let's go ahead and open up my colors. Where'd you go? .r. What was it? So it's custom color scale. I can add that here to get my coloring scheme up, and that needs parentheses because it's a function. And so there's my coloring scheme that looks pretty nice. We can change the labs. Actually, I think I mentioned this before. I like making the theme stuff the last aspect of my ggplot workflow. And so that's good. And let's go ahead and put labs. And so X, number of copies of rRN operon. And I'm putting the star around rRN because I'm going to want that italicized. And I'll remind you how we can do that. And we've done that in a previous episode. For Y, then, I'm going to do threshold distance, threshold where 95% of species have one OTU, like that. That is quite long. We'll put a line break in here, probably right about there, but we'll revisit this when we actually generate the TIFF or the PDF. Same goes for the x-axis. I think it's okay for right now, but let's see what we'll do. We can move that legend to be inside the plotting window with theme and legend.position. And then we can give it the binary coordinates, and it's relative to the rest of the plot. So with x-axis first, and then y-axis. And usually it takes a little bit of tweaking to make that look right. And you know what? Right now, I'll go ahead and do gg save figures, and then copy number threshold plot dot PDF. Let's open up that plot. So that looks pretty decent. Let's go ahead and make sure we've got the right size on our figure. And so we can do, I'll do width equals 5, height equals 5. And that looks pretty nice. One bit of feedback that I got on the rock curve was that the lines were too thin. And I kind of agree, looking at these lines, that they're a bit thin. So what I'm going to do is I'm going to make them thicker. And we can do in geom line, we can do size equals 2. And so let's give that a run and see what that does. It looks horrible in the lower right. It doesn't look much better here. Let's see, what does 1 do? I actually think the default isn't size equals 1. So let's see. I think that looks good. The lines are a bit thicker here than they are by default. So let's run with that. A couple other things that I want to clean up here. We talked about this before, that the legend is a little bit spread. So we might want to tighten that up. We need to make sure that we italicize the RN. And I want to make these integer values across the x-axis so they're easier to read. And I want to represent these as percentages. So again, so this will need to be a percent sign. And what we can do is up here with my scales, we can do scale x continuous. And we can then do breaks equals 1 to 7 value, or sorry, not 1 to 7, 1 to 9. And labels equals 1 to 9. Add a plus to that and build that PDF. And we see then that we've got our 9 copies across the x-axis. That looks pretty good. I think we could do like 1, 3, 5, 7, 9. Let's do that so it's not so cluttered on the x-axis. And so a trick to do that, so like 1:9 builds you a vector of 1, 2, 3, 4, 5, 6, 7, 8, 9. You could also do seek 1, 9, 2, and that will give you 1 through 9 by 2s. I think the syntax is actually seek from 1 to 9 by equals 2. So again, you can drop those argument names to make it look a little bit simpler. And so I will replace my 1 to 9 here and my labels 1 to 9 there, running all that. And so yeah, 1, 3, 5, 7, 9 looks good. Let's go ahead and replace the coordinate labels on our y-axis. Again, we're going to do scale y continuous. And we'll do breaks equals, so we've got 0, 0.2, 0.4, and probably 0.06. So we'll do 0, 0.2, 0.02, right? 0.04 and 0.06. And the labels we'll do 0, 2, 4, 6. Again, a different way to do this would have been to multiply the threshold column by 100. Let's leave the data the way they are. And so we see that we get not what we wanted. Why? Did I run that? No, I don't think I actually ran it. Yeah, there we go. 0 to 4, but we don't get 6. So we need to add the limit. We can go ahead and add lim its equals 0 to 6. Give that a run. And I use 6 because it's there, but what I really want to use is 0.06. So the limits you write are the limits of the breaks, not the limits of the labels. And so there we go. We've got 0, 2, 4, 6. Wonderful. That looks nice. The only thing I may be thinking that it would be nice to have 1, 2, 3, 4, 5, 6. Let's see what that looks like. Again, I could use the seek to do the same thing. Let's go ahead and do that. It'll make it a little bit tighter code. Seek 0, 0.06, 0.02, and then our labels 0, 6, 2. No, I want to do it by 1s, not by 2s. Okay. And so that's got 1, 2, 3, 4, 5, 6. Again, it's a little bit cluttered. Yeah, let's go back and do it by 2s. Again, so much of this is in the eye of the beholder and giving a nice, elegant appeal to your figure, making it look clean. And so that looks pretty nice. Let's go ahead and tackle this legend spacing. And here we can do legend key height. I think in previous episodes I used, what did I use? Well, let's look at the code. So down here at plot, lumpsplit.r, I used legend key size. And I think what that did actually was that it shortened the height as well as the width. So I'm going to replace this actually also with height. And while I'm here, I'm also going to make my geom line size equals 1. So that's also a little bit thicker. So again, the legend key height, let's try to use that here as well. And we'll build that. Again, we're doing a lot of iterating here, finding little problems in the figure that we don't quite like, and then improving it as we go along. So the next thing I want to think about is italicizing that label. And you'll recall that we did that with our library ggtext. And let me load that. Down here we can then do axis title.text, title x. And then we can do element markdown. Let's give that a shot. And that should then italicize. Yeah, we see that it italicized the rRN. Kind kind of a cool thing that we can do, huh? One other thing that I don't quite like is that this title on the y-axis seems really close to the labels for my y-axis. I'd maybe like to add a little bit of margin to the title so it's not right up against the numbers on my y-axis. Of course, we can do that with our theme function, where we can do axis title y, and we can then do element text. So we're going to modify the text, and we're going to do that by setting the margin to be margin, and you can then give it the top, I'm going to say 0, right equals 0, bottom equals 0, and then left equals 0. And those are the defaults. And so the top, I think, is fine. And I'm never quite sure if this up here is the top or over here is the top. So we might need to do a little bit of fiddling. So I'm going to go ahead for right and put an extreme value like 10 and see what we get from that. And so, yeah, that it did put a little bit of spacing here, and it doesn't seem that extreme, really. I think that actually looks kind of nice. What happens if we put in a 5 instead of a 10? Yeah, let's go back to 10. And I think that looks much nicer. And looking at this y-axis label, I think I want to make it clear that it's where the ASVs from 95% of species have one OTU. And so maybe I'll want to move that line break to there. Again, let's give that a run. Yeah, I think that looks pretty decent. And so I think this will make a really nice figure 1. Again, shows that as you increase the number of copies of the RN operon, you need to increase the threshold to collapse all the ASVs from a genome into one OTU. All right. So before I forget, why don't we go ahead and recreate that figure lump split.pdf, and I'm going to open up my project in Atom. So if I come down to where I've got all this stuff going on, there's a few things that we want to clean up. So these are our ESV rate, our lump split, the rock curve, we're going to want to get rid of. Let's go ahead back here to the terminal, and I will go ahead and remove those. So if it's under version control, you need to do git rm. You need to use git rm to remove it from the repository. So we'll do rock curve, and then I'm going to put a star to remove both of those files. And we see that it deleted both figures, rock curve PDF, and rock curve.tiff. And we see all the other changes we've made, of course. So figure 1 is going to become S1. So I'm going to move this down here. And my highlighting is not working. Here, so figure 1 then is going to become our new figure, which I called, what did I call that? That was in figures and copy number threshold plot. .tiff, right? And then that is going to get outputted as figure1.tiff, and that should be good. And down here, I don't want rock curve. I want copy number threshold plot.pdf. So I think that all looks good. Let's go ahead and make it. I know that the caption titles will be wrong, but again, we're working in stages. No rule to make, copy number threshold plot tiff. All right. Oh, and I didn't create a rule for it, right? So I need to create a rule to build this. And this will be PDF. And then it'll be code / plot copy number threshold .r. And then the dependencies are going to be the code colors.r. And let me come back to RStudio. And what was the name? Yeah, this script, the thresholds for single OTUs, will be the other dependency. And then we can then do code. We can do this, right? And we've seen before that there's actually automatic variables that we could use instead to do that, but that's okay. We also need to make this executable. So I will do chmod plus that to run that. Okay. And now if we try and make that, maybe I forgot to save this. Oh. There we go. And I forgot a backslash at the end of this line. So I got an error saying permission denied. I think it was trying to run that as an executable. And so I forgot to continue the line with that backslash. All right. Now it should work. So many problems. Unexpected no token near line 1. Oh, I forgot the shebang line, right? So hopefully, as you see me coding here, you'll realize and appreciate that all these errors are totally honest and just part of the learning experience. Okay, so now I've added my shebang line. I think it should work now. Yeah. No, what? You know what? Now that I look over here and see that I've got the PDF, but I didn't save a TIFF version of that. So I'll want to be sure to do that. Oh. Remake it. Hopefully this works. Hey, it compressed, and now it's rendering the document. All right, so it ran through it, and it's complaining that it can't find figures.curve.pdf. That's fine. Let's go ahead and open up our manuscript. And if we come back down to the bottom here, again, this is that rockcurve.pdf. And what we want instead is copy number threshold plot.pdf. And actually, I'm going to get rid of all of this. And what we're going to do is we're going to move things around, right? This is going to become figure S1. And right, so that's the ratio, it's the ESV rate. The lump split is still going to be figure 2. And we're going to want to create a new figure here. And so you all don't have to watch me type. I've already put in, written up some text for this caption, which I think does a pretty good job of describing it. So we also need to modify the text up here in the manuscript. I need to get rid of all this stuff about the rock curves. I really loved this analysis and thought it was cool. But in the end, yeah, when you have such wide differences in the number of positives and negatives, it really doesn't make sense. And so this second paragraph is the one that I'm breaking apart into 2 parts to look at the threshold you need to collapse all those ASVs down to a single OTU for every number of operons, as well as the lumping and splitting plot. So I've already written some text, so you don't have to watch me type. And we've covered this, these code blocks and how to insert code in other places. So I've pasted that all in. We'll go ahead and save this now, and I'll go ahead and make out the manuscript, and hopefully it looks good. So looking at our manuscript again, we still need to work on the abstract and importance section. We also need to get a better title. And you'll recall that the first paragraph is an introduction. This is a short form manuscript, so everything is a little bit more compact than it would be in a full form manuscript. This first paragraph of the results section then talks about the rate of ASVs per copy of the rRN operon. And then we talk about splitting, and then we also talk about the risk of lumping. I might consider pulling those together into the same paragraph. I'm not going to worry about that right now. I still need to do a fair amount of editing to the manuscript to make it look good enough to be ready to submit. So I've got all the information here. We still need to go over it and clean things up. And then we have a final paragraph with conclusions and discussion, as well as then the materials and methods. Let's look down at the figures to make sure those all look right. So here's our new figure 1. That looks great. And our figure 2 with the splitting and lumping. And then our figure S1 now is these rates of ASVs per copy of the rRN operon. And that looks great as well. Good. So I think this is going to do it for today's episode. I think we've, again, shown the value of letting your analysis sit for a bit and breathe. Now, at the same time, don't get me wrong, this should not be confused with procrastinating. On behalf of PIs everywhere, please do not procrastinate on your projects. But I think it is useful to kind of have a set amount of time that you perhaps set the manuscript to the side and then see it with fresh eyes, whether that's thinking about your analysis or editing the text. Sometimes we work on our papers, our projects so much that we know it so well that it's obvious to us. But all the blind spots that appear then or don't appear because we know it so well. And so one strategy is to set it to the side and then see it with fresh eyes so you can, identify those blind spots. Another thing, as I talked about earlier, is to share the story with other people and have them help you find the blind spots. That works again for thinking about your analysis as well as the editing phase, which we'll do here in a couple episodes. Thanks again for spending your time with me to work through this analysis. I know sometimes it feels like we go 2 steps forward, 1 step back, or 1 step forward, 2 steps back even. We spent a lot of time building those ROC curves over many episodes, and it's kind of dispiriting to just delete it and have it just disappear. Of course, it's still there in our version control, and we're not totally chucking it, but at the same time, it's not relevant for this analysis, we've come to realize. Anyway, thanks again for spending your time with me. I know that this is a time investment, and I hope you get something out of seeing me work through a project and all the, the strategies I have and all the problems I run into. This is all real. This is a real project that I'm working on with you. The only difference is you're watching me do it, which is a little bit scary. It's kind of like programming in just my underwear or something, which thankfully I'm not doing. Anyway, let me know down below in the comments, what are some of your strategies for identifying blind spots in your analysis or in your writing? What do you do to help you realize where you're making assumptions that your reader isn't there with you, okay? Anyway, keep practicing, and we'll see you next time for another episode of Code Club.